This question belongs to algorithm subject and the topic name is time complexity. It was asked in GATE 1990. So the question states, choose the correct alternatives. The complexity of comparison based sorting algorithms is order of n log n, order of n square and order of n root n. So what are these comparison based sorting algorithms? So we have two types. We can classify the sorting algorithm in two types: comparison based and non-comparison based. All the algos, standard algos like bubble sort, heap sort, merge sort, quick sort, selection sort, insertion sort, all of them come in the comparison based sorting algorithm. What is the meaning of comparison based? Let us suppose we are sorting these 13, 1, 5. Then at any point we need to compare two items and check whether A is greater than B or not. These are meaning of comparison based sorting algorithm. And what are non-comparison based sorting algorithms? These are like radix sort, count sort, bucket sort. These comes under non-comparison based sorting algorithm. As here, we are not directly comparing the entire number. We may be comparing a particular digit of a number, like the ones place or tens place, but not the entire number. So they come in non-comparison based sorting algorithms. So the question is asking the complexity of comparison based sorting algorithms is what? So here we can easily see that there is no standard algo that is being given to us. Like we have not asked like the complexity of merge sort or the complexity of heap sort. So any standard algo is not given to us. So we need to go by general cases. We need to go by general case of proofs. So now let us see. Let us see the meaning of this theta notation. So what is this theta notation? There are three types of notations: big O notation, omega notation, theta notation, as well as small o and small omega notation. So what is the difference between these big O, omega and theta notation? Let us suppose we have the complexity n square. So we can write n square as big O of anything greater than or equal to n square. Like we can write it big O of n square, we can write it big O of n cube, we can write it big O of n to the power 4. Anything bigger would come over here, which means n square is less than equal to anything on the right hand side. And what is the meaning of omega? Anything smaller we can write over here, smaller or equal to. Like we can write it is equals to, let me write greater than equal to over here. We can write n square equals to omega of n square, it is equals to omega of n. We can write it to omega of n log n. We can write it omega of 1. Anything smaller we can write on the right hand side. And what is theta notation? Let us suppose anything which is both big O and omega. Let us suppose we can write n square both as omega of big O of n square, as well as we can write it as omega of n square. So n square is equals to theta of n square, which means it has both the upper bound and lower bound both are same. Then we can write it as theta of n square. Now let us see the options. Here we can see that we have been given the theta notation. Now what we know? We know that in the heap sort, we know that in heap sort and in merge sort. What is the complexity? We know that all the cases is big O of n log n, which means in every case, which means in the worst case also we will get big O of n log n. In the worst case also, the complexity is big O, which means it is less than equal to order of n log n. Now to find theta, we have to also prove that the time complexity is less than equal to, we have proved this order of n log n. So we have to prove it is greater than equal to omega of n log n. Then only we can say it is equal to theta of n log n. If both the cases happens, then we can say t of n equals to theta of n log n. This one, the right hand side, we can easily see from bubble sort as well as heap sort, and we have to prove this one. Now let us see how we can give a proof for this one. So let us suppose we are sorting a list of n items. Then we can have only one output. Then what are the various permutations that can happen? Suppose we are sorting 5, 3 and 2. So what are various permutation of sorted? It can be either 532, 352, 523, it can be 325, it can be 235, it can be 253. So for n items, we can have n factorial permutation. We can have n factorial permutation. But see, only one of these permutation is correct. So which means what we have to do? We have to basically, let me not remove this, yeah. So what we have to do? We have to basically, we will be given n items and we need to combine this n factorial permutation to a single permutation. We need to combine this n factorial permutation to a single permutation 235. So let us see what happens. Suppose, let me give you the proof like this. Suppose we have items like 5, 3 and 2. Then what can happen? We can have all the items in which 5 is greater than 3 over here. We can have 5, 3, 2. We can have over 5, 2, 3. We can have over here 2, 5, 3. And all the items in which 5 is less than 3. Here 5 is less than 3. Here 5 is greater than 3. Like 3, 5, 2. And then we can have 3, 2, 5. We can have 2, 3, 5. Here we can see 3 comes before 5. Here 5 comes before 3. So when we are comparing two items, then we are basically, if we compare 5 and 3, we come to know that 3 is less than 5. So we know that this is discarded. Which means we every time using one comparison, we are reducing the set by 2. We are dividing the set by 2. If it was n factorial, then after one comparison, it will become n factorial by 2. After two comparison, it will become n factorial by 2 square. Then it will boil down to 1 at the end. And again, now let us suppose we will compare 2 and 5. And we will come to 2 is less than 5. Then we can discard this. So every time we are just dividing it by 2. Then we will compare 2 and 3 and we will get to know that 2 is less than 3. So we will discard this. So what are the steps in going from n factorial to 2? We are dividing each time by 2. So we can see that we will have log n factorial steps. And what we can write log n factorial? We can write log n factorial to be equal to omega of n log n. It's a standard equation that n log n factorial can be written as omega of n log n. Which means we have the complexity omega of n log n to find the sorted array. Now let me brief it up. So what I have told you? I have told you the meaning of theta. When we have upper bound as well as lower bound, both equal to same, then we can write it to be theta. Here we cannot use any standard algorithm. Now let us suppose we have n items, then we will have n factorial permutation. Each comparison reduces the size by 2, so n factorial to n factorial by 2, then divide by 2, then divide by 2, till we will get this sorted array. Here what will be the number of steps? Number of steps will be equal to log n factorial. Log n factorial can be written as omega of n log n. Thus we have best case as omega of n log n. And we got order of n log n from bubble sort and heap sort analysis. Not bubble sort, heap sort and merge sort analysis, as they have all cases omega of or order of n log n, which means every case less than equal to n log n. Thus if we can write both omega and big O, then we can write time complexity equal to theta of n log n. So answer is option A, theta of n log n.